We are going to work our way through this 5.6 to 5.9 quiz. We'll be going over concavity, inflection points, derivative relationships, first derivative and second derivative. So here we go. At which values of x does the graph of f have a point of inflection if the second derivative is 3x times x minus 2 squared? Well, we know that a point of inflection occurs when a graph changes from concave up to concave down. And we can tell if it concavity by the second derivative. So what we're going to do is we're going to set the second derivative equal to 0. And the reason we're doing that is if the second derivative is positive, the graph is concave up. If it's negative, it's concave down. So if it's 0, it could pass from positive to negative. So by looking at this, we see that either x equals 0 or x equals 2. And so what we can do is we can look for sign changes here. And so I'm just going to make a little sign graph or table here. Here's 0, here's 2, and I'm going to pick values in each of these three sections to see if the second derivative would be positive or negative. So first of all, I'm just going to think of a really large negative number, maybe negative 10. If I had negative 10, looking at, I'm not going to do the exact values, but 3 times negative 10 would be negative, and then negative 10 minus 2 squared would be a negative, but it's squared. So we have a negative times a positive, which is negative. So this is a negative. Let's put 1 in there. With 1, we can be more specific, but really positives and negatives are what matters. So 3 times 1 is positive. 1 minus 2 is negative, but it's a negative squared. So we have a negative times a positive, which is positive. And then let's pick a number larger than 2. Again, it could just, you could think a huge number or whatever, just anything to the right of 2. So if we put 4 in here, this would be 12. And then 4 minus 2 is 2 squared is still positive. So this is positive. So the only place that this changes signs is at 0. It was negative to the left of 0, positive to the right of 0. We could be more specific. This is concave down changing to concave up. But which values does x have a point of inflection? Just at 0. Moving to the next one, the second derivative of a function of f is given by f double prime of x is x plus 1 times x minus 3. At which value of x does the graph change concavity from concave up to concave down? So this is a lot like the question we just did. What we want to do is we want to find when the second derivative is 0 and then see the sign changes around those numbers. So nice and simple, this is equal to 0 when x is negative 1 or x is 3. We can do the same idea. We got negative 1 and 3. Plugging in values, if you put negative 4 in here, negative 4, so something to the left of negative 1 would give you a negative times a negative, which is positive. Putting 0 in there would give you a 1 times a negative 3. 1 times negative 3 is negative. And putting something like 4 in there would be 5 times 1, which is positive. And so it asks concave up to concave down. So we have 2 points of inflection at negative 1 and 3, but concave up is when the derivative, the second derivative is positive. So concave up to concave down, positive to negative, is at negative 1. All right, number 3. The first derivative, so the other ones were second derivative, the first derivative of a function is given by f prime of x is x cubed minus 3x, on which intervals is the graph of f concave down. Well, we weren't given the second derivative, but we can pretty easily find the second derivative. So the second derivative is 3x squared minus 3. And we want to find when this is 0, and so this is very similar to the questions before. While we're doing that, we can go ahead and factor out a 3. And so this factors to x plus 1 times x minus 1. And so values of that make that 0 are negative 1 and 1. We can put those here. So just thinking, putting in negative 2. Negative 2 would make this a negative and this a negative, so that would be a positive. Putting 0 in, 0 would make this equal 1 and this equal negative 1. So 1 times negative 1 is negative 1. And putting something like 4 in would make this 5 times 3, which is positive. And so on which intervals is the graph of f concave down? Concave down is when the second derivative is negative, so that's from negative 1 to 1. So choice B. I'm rounding up the page here, page 1, let f be a function. So the first derivative is 0, and the second derivative is less than 0. Second derivative of x is less than 0, so realize that means it's negative, which means this is concave down. So we've talked about that a bit. What does the first derivative equaling 0 mean? Well, the first derivative equals 0 is a critical number, and we know we can use first and second derivative tests to, really the second derivative test in this case, to figure out what's going on there. Well, the first derivative is 0, which means the slope is 0 at an x value, and the second derivative is negative, which means it's concave down, so it looks like this. And so we know that there is a maximum at x. Now, this is really not written correctly. These shouldn't say 0 here at all. We just know that f has a relative maximum at x, at the x value here. We don't know what that x value is. I apologize. So this is B.